Okay, so in this problem, we're going to have to write an equation. We're going to have to determine which one's the limiting reagent, figure out how many moles of product it makes, and then the mass of product, and then grams of excess reactant. Ooh, okay, so that's interesting. So first steps first, we're going to have to write this reaction and then balance it. So it tells us that silver nitrate reacts with iron 3 chloride. So silver nitrate, AgNO3. And I know that it's, well, I know it's Ag plus, because that's the charge that you have to memorize. And nitrate is NO3 minus. So when you add them together, it's 1 to 1. So it's 1 plus and 1 minus. And then iron 3 chloride. So the iron 3 tells us that this iron has a 3 plus charge. And chloride having a 1 minus charge, means we're going to have 3 chlorines to match this 3 plus. All right, to produce silver chloride, so AgCl, and iron 3 nitrate. So iron 3 nitrate. And again, same idea. Nitrate is 1 minus. Iron, they tell us it's 3 plus. So we're going to need 3 nitrates in total to balance out the iron. Okay, so next step is we're going to have to balance the overall equation. Let's check. Starting with silver, looks like silver, 1 silver, and then 1 silver. Okay, this is, so over here we have 1 nitrate, and over there we have 3 nitrates. So what I'm going to do to balance that is, I'm going to go ahead and put a 3 over here, triple everything. Unfortunately, once we do that, that means we now have 3 silvers and 3 nitrates. So we're going to need to adjust our silvers. Looks like what I'm going to do is I'm going to put a 3 in front of this silver chloride. So now that we have 3 and 3 for everything, let's go to the next one, iron. Okay, iron. Looks good. We have 1 iron on the reactant side, 1 iron on the product side. That's good. And then last but not least is chlorines. There's three chlorines on the reactant side and 3 chlorines on the right side. So we're good. This is balanced. Just gonna get rid of this because I'm gonna need the space later. Okay. All right. So first off, I'm just going to list the states of matter. This is kind of optional, but it's always nice to know what state of matter you're working with. And if you want to know these, it's going to have to be, you're going to have to know your solubility rules. I won't go over them right now, but we have a video on it where it's about how to tell if something's a precipitation reaction. But basically, nitrate is soluble, this is soluble, but this forms a solid. So when you mix in these two things, you're going to create this one solid and the rest of this liquid. Okay, let's see. Next step is find the limiting reagent. And they tell us we have 25.0 grams of this. All right, and 45.0 grams of this. Okay, so first things first. What I usually like to do is I usually like to turn our reactant into one of the products so we can see. So we can compare the limiting reactant. In this case, I'm going to choose silver chloride because we're going to need that number for the rest of our calculations anyways. So 25.0 grams of silver nitrate. And then I have to find the molar mass. So 1 mole of silver nitrate is going to be, silver is 107.87, I believe, plus 14.01 plus 12.01 Oh, that's not right. So 4 plus 14.01 plus 16 times 3. Okay. So we should be getting 169.88 grams. And then we're just going to convert from silver nitrate to silver chloride. So for every 3 moles of silver nitrate, and I want to make sure this is nitrate so it cancels out with this nitrate, and I get the 3 from the equation right over here. Every 3 moles of silver nitrate is equivalent to every 3 moles of silver chloride. And this is where I'll stop. I also do the same thing with our iron chloride. Just going to run through that quickly. Iron chloride, iron 3 chloride. Let's see. What is the molar mass of iron 3 chloride? I'm just going to Google this one. Molar mass, okay. Looks like we have 162.2 grams. Now we're going to turn this one into silver chloride again. So immediately I know I want the top to be silver chloride, and I want the bottom to be iron chloride, so I can cancel this out. Now looking at our reaction, looks like it's 1 to 3. So for every 1 mole of iron chloride, we make 3 moles of silver chloride. All right, now we just have to calculate these numbers. Times 3 divided by 3. This should be 0.1472 moles of silver chloride. And this one should be 45 divided by 162.2 times 3. Did I get that right? 45 divided by 162.2 times 3. Okay, so that's what I got. So that's 0.8323. Okay, so when you're looking for the limiting reactant using this method, you always choose the one that's smaller product. So in this case, this is the limiting reactant. To give a quick analogy, it's kind of like, say you had a recipe that tells you for every 2 eggs and 1 flour, you make 12 cookies. Now if you have, let's say you have 2 eggs, or let's say you have 1 egg and you have 1 flour. If you try to see how much you can make from these ingredients alone, you see that if you had 1 egg, you could only make 6 cookies maximum. Because you need 2 eggs to make 12, so 1 egg is going to only make you 6. If you have 1 flour, you could make 12 cookies in total, because that's what the recipe says. However, you don't have the 2 eggs you need for the 12 cookies, so this is going to be the smaller one, which means it's the limiting one. It's just like a quick explanation. So this tells us that Ag, NO3, limiting, and iron chloride is excess. All right, I'm just going to move this a little bit up. Okay, so that was B. You're able to identify the limiting reagent. For C, they're trying to ask us what is the maximum number of moles of silver chloride that can be obtained from this reaction. So if you look, we can already see that we solved that. With the maximum number of moles of silver chloride, the maximum amount we can create is going to be this much, because we only have enough of this to make this much. So we could never reach this amount, which is the maximum if we had this much of the other reactant. So this tells us that our limiting reactant tells us the maximum amount that we can create. So this would be C, which is going to be, I'll just write it in total. D asks, what's the maximum mass of silver chloride that can be obtained? So they don't want the moles in this time, they want the mass. So whenever you go for moles to mass, you're going to have to use the molecular weight, the molar mass. Make sure things cancel out. I want moles on the bottom, so I can cancel out the moles. Now for every 1 mole of silver chloride, there are 7.87 plus 35.45. 143.32. Okay, there are 143.32 grams. Let me just double check that. Silver chloride molar mass. Yep, that's about correct. So doing this, we cancel out the moles over here, and we're going to be left with grams of silver chloride. So how many do we create? 0.1472 times 143.32. Looks like we end up making 21.09. Well, I'll just go ahead and round it early. 21.1 grams of silver chloride. Okay. So that was fairly straightforward. We just found how many grams we had in terms of moles. Next, it asks us how many grams of excess reactant will remain. This is a little bit more complicated. So, to do that, you are going to have to, let's see. All right. Okay. So here's how we're going to set it up. Oops. With our 25.0 grams of AgNO3, we have to, well, basically we started with 45.0 grams of this iron chloride. And since this is an excess, we used it up and we're going to have some extra left. So what I'm going to do is I'm going to find out how much we used up. So to do this, it's a lot like this problem right over here. So what you do is you start by turning this into moles. So for every 1 mole of silver nitrate, you're going to create, well, no, 1 mole of silver nitrate is going to have 169.88 grams. And then it looks like, all right, my next step is going to be figuring out how many moles of this iron chloride we're using up. So I want silver nitrate to be on the bottom so I can cancel it out. And on top, I want the iron nitrate. Sorry, iron chloride. Okay. Oh, sorry about that. I'm going to have to adjust these moles. We're going to use 3 moles for every one of these. Okay. And then what I'm going to do is turn these moles of iron chloride into grams using the molar mass again. So this time I'm going to need the mass of iron chloride. I have it up above, 162.2 grams. So this is going to be, once we calculate this, 0.88 divided by 3 times 162.2. Double check the math. Yeah, looks correct. Okay. This tells us that we ended up using 7.957 grams of iron chloride. So this is the amount we used up. So out of our initial 45 grams, we used 7 grams of this, which means we're going to have like 38 grams left over. So to just do that math, you're just going to have to subtract both of them. 169.8 times, okay. So to do that, it's just going to be 45 minus our 7.9857. Or just going to go ahead and say this is grams of iron chloride. So once we calculate that, 45 minus 7.957 looks like we're getting 37.043. And if we stick with sig figs, we only have 3 sig figs. So that's going to be 37.0 grams iron remaining. So this is the iron used. This is the iron we start with. We're going to end up with 37 grams of iron remaining. All right, that's problem 1. There you go.